All right, today we are starting section 7.5, our last section of chapter 7. Our objective is to use the triangle proportionality theorem and its converse. So we will still be dealing with similar triangles, but we will not be proving them to be similar. Instead, we're going to talk about relationships within triangles using the triangle proportionality theorem. The triangle proportionality theorem states that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So in symbols, or in this diagram down here, in triangle QRS, if we've got TU and QS parallel to each other, so TU is the one cutting somewhere in the middle of the triangle parallel to that other side, then RT over TQ, that ratio, is equal to the ratio of RU over US. So those pieces are proportional. Previously, we were comparing pieces to the full side, like we would compare RT to RQ. Now we're just breaking it into little chunks. All right, on example 1, we've got triangle RPS. We've also got the segment QT parallel to side RS. That's what those little triangles mean. And so we are going to be able to set up a proportion between the pieces of these sides. Okay, so if it is still small, this section is labeled 32. This one's 16. Down here, we've got X and 12. So in order to find the value of X, we're going to set up a proportion. I would always recommend picking one side to start with. So it doesn't matter to me which side do you want to start with, PR or PS? PR, okay. So if we start with PR, we've got to choose one section to go over the other section. So I prefer to start at point P. The first section is 32, and that's going to be put over the 16, the other chunk from that same side. When I do that, and I go to set up my other ratio, I have to start again back at point P. So my first section is X, and that other section in the back is 12. This is not the only proportion we could have set up, but it's one that works for us. All right, in order to solve it, we need to cross multiply. All right, so we have to take 16 times X. What does that give me? 16X, and we have to take 32 times 12. 384. In order to get X all alone, we need to divide by 16, and we get X equals 24. Okay. Wonderful. Questions about how we solved that one? All right, when we go to set up the proportion on this one, there are multiple correct ways to do it. Does anybody have an idea of what they want their proportion to look like? This is a letter D down here. All right, so if we start with the top side, we could put 10 over X equals, what would the corresponding parts be of that other side? 8 over 4. Good. Okay. We cross multiply and we solve. When we cross multiply, what do we get? 8x equals 40. And then to solve, we have to divide an x equals 5. Can anybody help me set up my proportion? Okay, 16 over 12. Yes, this is point L up here at the top of the triangle. So if we start with this left side, 16 goes over 12. What would the corresponding ratio be for the other side? Good, 20 over y. In order to solve this, we have to cross multiply and solve. 16 times y. 16y equals 240, good. And then we divide and y equals 15. Wonderful. If I want to just represent this big chunk of the bottom side, the whole thing is 24 and this little part is y. So does anybody know how I could represent that part? Keon? We're not setting it up yet. We're just trying to identify how we would represent just this chunk of the bottom side. Nobody's quite sure how to represent it? If I told you that instead of y, that this section were to be, for example, 1. This section's 1. How long would this section be? 23. How'd you come up with that? Subtraction. So it's the same thing. We can represent this by calling it 24 minus y. So that is how we are going to represent that larger chunk on the bottom. Okay, so let's start with this slanty side to start setting up our ratio. 12 over 20. I like it. We are going to set that equal to, should that go on the top or the bottom? The bottom. What should go on the top? The y. The 12 corresponds to the y. So if the 12's on top, the y has to be on top, which means the 24 minus y goes on the bottom. Okay, now we have to cross multiply. When we cross multiply 20 and y, that's easy. What do we get? 20y equals, but now when we go to cross multiply the 12, what do we have to remember to do? Distribute it. That 12 gets multiplied to the 24 and to the y. All right, so 12 times 24, 288 minus 12 times y is still 12y. I'm running out of room here. All right, so there's a 12y over here. It's just getting cut off on the board. In order to get y by itself, what do I need to do to both sides? Add the 12y to both sides. Good, so that leaves us with 32y equals the 288. And then finally, to get y all alone, we have to divide. Good, so y equals 9. So if they do give you the whole side length, you have to know how to represent that other chunk using subtraction. The converse states that if a line divides two sides of a triangle proportionally, then that line is parallel to the third side. So it goes the other way. This time, instead of knowing that the lines are proportional, we are going to show that the lines are proportional. Sorry, that the lines are parallel. We know the segments are proportional, which we'll be able to show the lines are parallel. All right, if we are trying to show that these are parallel to each other, we're trying to decide if they are parallel or not. If they're going to be parallel, these need to be in the same proportion to each other in the same way that we've been setting these up so far today. Okay, so there are a couple different ways we can go about showing that they are proportional. One would be to set up the ratios, reduce them, and show that they reduce to the same ratio. If you want to do it that way, that's fine. But I'll show you another way to do it. If we were to set up the proportion the same way we were doing before when we had a variable, how would we set up this first fraction, this first ratio? 10 over 16, and the other one would be 9 over 12. So if we are wondering if these are proportional to each other or not, we can find the cross products, so we can still cross multiply and see if we get a true statement or not. Now when we cross multiply these, 10 times 12, what do we get? 120. And then we take 16 times 9, what do we get? 144. So, do these come out to be equal? No, they are not equal. So if your cross products are not equal, then those ratios are not proportional. So is BE parallel to CD? No. So you can either just show the work to show me that, or you could say segments not proportional, something along those lines, so I know why you're giving me that answer. Cross products not equal, sides not proportional, segments not proportional, something along those lines to explain how you came to that decision. Questions on 5 before we move on to 6? Number 6 is the same idea as number 5. We're going to set up a proportion and then decide if it is in fact proportional. What could I put in my first ratio? 21 over. The 21 would go over what? 28, good. Okay, and then my other ratio would be? Good, 24 over 32. When we cross multiply this time, what do we get if we take 28 times 24? 672. What about 21 times 32? 672. So do we think that these are proportional? So do we think BE and CD are parallel? Yes. So yes, segments are proportional. Oops, I got a little cut off over there. So yes, the segments are proportional. That's how we know that BE would be parallel to CD. Okay, we will stop our 7-5 notes there today and pick up on it tomorrow.